The discriminant is just a number which describes the roots of a quadratic, and the value of the discriminant is the number that you get in return after evaluating b squared minus 4ac. So that should look familiar to you. B squared minus 4ac comes from the quad formula, which is x equals negative b plus or minus the square root of the discriminant over 2a. So now, describing the roots, it'll be really important to remember where this comes from. It is in the quadratic formula, it is under a radical, and we are adding and subtracting this number separately. So just knowing that this number lies under a radical will help in your description of roots of quadratics. So let's just think about some possible output values for b squared minus 4ac. Well, it can either be negative or non-negative. Well, if we have a negative number for b squared minus 4ac, that means we have the square root of a negative number. Well, that is imaginary. That means b squared minus 4ac is less than 0, which are imaginary roots. B squared minus 4ac is negative, imaginary roots. Well, if it's non-negative, that means b squared minus 4ac is greater than or equal to 0, and these are real roots. It means they really do cross the axis. Somewhere, I just don't know how. Well, if it's non-negative, that means it could either be 0 or positive, which means b squared minus 4ac is 0, or b squared minus 4ac is greater than 0. Well, if b squared minus 4ac is 0, let's think about that. If b squared minus 4ac is 0, that means you have x equals negative b plus or minus square root of 0 over 2a, which is x equals negative b over 2a. Well, that plus minus is the only reason why we have two solutions for a quadratic. We're adding and subtracting 0. So that means we're going to have one solution here. So they call that equal roots. Now what that means is really you have one root. Okay, so equal roots. Again, one root. I don't know why they say equal roots, because if you have like x minus 5 times x minus 5 equals 0, and you were to solve by factoring, these are two roots, just that they're equal. That just means it's crossing the x-axis once. So that's why they say equal roots, because if you were to solve by factoring, you would have gotten the same number in return. Well, if we have a positive number, well, there's two types of positive numbers that you can have. You can either have a rational number or an irrational number. How can you characterize or draw a distinction between a rational number and an irrational number? Well, an irrational is a non-perfect square. And a rational number is a perfect square. Both of these here mean that we have unequal roots. Two different numbers in which they can be either rational numbers, a fraction, or irrational numbers, a radical. So these are all of the different ways to describe roots of quadratics. So either they don't exist or they do exist. Is it negative or is it not negative? Well, if it's not negative, then guess what? We can describe it even further. Are they the same or are they different? Is it 0 or is it greater than 0? Well, if it's greater than 0, we can describe it even further. The unequal roots can either be rational or irrational. Do we have a perfect square? Or do we have a non-perfect square? Let's use the discriminant to describe the roots of these quadratics. These are 4 different quadratic equations in which we'll describe the roots using the value of the discriminant. So b squared minus 4ac in this case is negative 4 squared minus 4 times a, which is 4, times 1, which is c. Negative 4 squared is 16, minus 16, 0. So the value of the discriminant is 0. What that means? Well, they're real. It's not negative. they're rational, it's not a radical, and they're equal roots, meaning I'm only getting one solution. Let's evaluate b squared minus 4ac here. Negative 3 squared minus 4 times a times c. Negative 3 squared is 9. Negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8, 17. Remember, this is the discriminant. This number's under a radical. So these are irrational roots. Not only are they irrational, they are unequal. We will get two different numbers. And not only are they unequal, they are real. So these are real, irrational, and unequal roots because of the value of the discriminant. Let's evaluate the discriminant here. b squared minus 4ac here would yield negative 4 squared minus 4 times a, which is 1, times c, which is negative 12. 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 12. Negative times a negative is a positive, and 4 times 12 is 48. So let's clean this up, and we get 1464. Well, guess what? If this were a radical, I can take the square root of that number. That's telling me that they are rational roots. That's also telling me that I have real roots. Why are they real? It's not negative. Why are they rational? It's a perfect square. And they're also unequal because I am adding and subtracting something. And in this case, b squared minus 4ac yields 2 squared minus 4 times a, which is 3, times c, which is 5. 4 minus, let's see, 15 times 4 is 60. So you get negative 56. Well, these are imaginary roots. Why these imaginary roots? Because the number under the radical is a negative number. Last thing we'll do, we'll just look at what the graphs will look like. If we have graphs of discriminants, if we have imaginary roots, that means b squared minus 4ac is less than 0. What that's telling me is that I have something that looks like that, or I have something that looks like that. It's just not crossing the x-axis. Its position isn't important, whatever quadrant it's in, but the graph is not crossing the x-axis. Imaginary roots. The roots do not exist. If I have equal roots, that means b squared minus 4ac equals 0, and that would look like this. Either that or that. The graph will be tangent to the x-axis, meaning we're only crossing the graph once. We're crossing the x-axis once. Now, having the discriminant being 0, that means your solution is x equals negative b over 2a. Well, isn't that the equation of the turning point, the equation of the axis of symmetry? That's exactly where we'll cross the x-axis, at the vertex of the quadratic. If we have unequal roots, that means b squared minus 4ac is greater than 0. Well, then our graph would look like that, or like that. I know it's crossing at two different spots. Now, I would not be able to characterize these as either rational or irrational just by looking at its graph, but I would have to know these values to determine, is that number a radical, or is that number a fraction? Is that number a radical, or is that number a fraction?